Alright, so now we're going to look at how we would get the area under the curve of the distribution function. But the main problem with that is the function itself is quite complicated. As you can see, it's equal to the sigma notation over 2 pi of e raised to minus 1/2 times x minus mu over sigma raised to squared. Now, as you remember, when we were studying it using Excel, it looked like this. Alright, now the aim is for us to get the probability if we
A
say that
vast
something
virus
is,
database has been
like for
updated.
example, the mean is 10, and since this function tells us what the probability for a certain area is, if we wanted to get the probability of getting at most 10, for example, or let's say at most 9, then that means that the highest number that you need to get is 9, which is right there. And it also means that at most 9, so then it needs to be everything that's less than 9 would also be included. So it's getting this area right there. Now, in calculus, the way to get that is for you to sum all the possible points along this curve from here to 9. The problem with that is this curve doesn't end. The actual end of this curve is negative infinity. So how do we sum all of those things from negative infinity to 9? So the way we can do that is using the integral function. So we start at negative infinity and then we end at 9 of the function above. So let me just write it down here. E raised to minus 1/2 of x minus mu over sigma squared. So that is something, this thing is something really hard to evaluate. So for us to do that, we can try to evaluate that, but the problem is evaluating this requires a lot of intense mathematics. So what we do is we try to change this thing into what we call as the cumulative distribution function. And this would help us a lot in understanding or actually getting the answer. Instead of evaluating the integral, we use the cumulative distribution function and use Excel to find out what the area of negative infinity to positive 9 is. Alright, see you again next video.